Hi, I'm Mark Verbos from Verbos Electronics. We're a maker of these modular synthesizer modules. The microphone's falling. I'm going to start out by talking a little bit about envelope generators. They're maybe the most boring synthesizer modules, so this will be a really boring, relatively quick history leading up to our new module. I don't know, it was fine up until I started and then suddenly. Synthesizers are relatively young. They started in the early 60s. And the earliest of synthesizers had very simple envelope generators. The simplest envelope generators are what's called attack decay and attack release. The difference between those two is that we see here is this is the gate that we're putting into the module, maybe from a keyboard or maybe from a sequencer, and then this is the shape that we're getting out. The difference between an attack decay and attack release is that an attack decay envelope rises up to a peak and then falls down, and it more or less ignores how long you're holding the key. It just runs its cycle all the way through, and that's the end of the story. And an attack release will hold on the top as long as you're holding the key down. But in those early envelope generators, they didn't have any logic to tell them that they should rise all the way up. If you were to put a very short spike into this one instead of a longer gate, it might just give up at this point, just as it starts, come down and not really give you much. And then it didn't take long. What you might find in those kinds of synthesizers would be that you want to have both of these happening in the same sound for two different things. Like you might use the attack release for the VCA and the attack decay for the filter. And then it doesn't take long before they combine those ideas together. We'll hold this one for a little bit later. To create what's called the attack decay sustain release, which is the gold standard for keyboard-based instruments. Sort of what we sometimes refer to in the synthesizer world as East Coast synthesizer philosophy. This is kind of in opposition to everything that I stand for. So I'm sort of known as a West Coast synthesizer type of guy, and that means that generally we like these simpler types, and we like to use them in funnier ways, like making them loop or chaining some of them together, or maybe using some other more complex techniques. But somewhere hiding in between all of these is the attack hold decay, which has a control to control how long the time at the top of the cycle. It's a bit like the attack decay, except with this additional time parameter for the holding. And this time, if you were to send a short spike into this, it would cycle through this whole time, but if you were to hold the key longer, it would continue to hold until it falls off. There are some more complicated shapes, which are more or less just adaptations of the attack decay sustain release, just to make things a bit more interesting or flexible. The nice thing about an attack hold decay sustain release is that this hold phase, which is a little bit like the attack hold decay, allows it to hold at the loudest point, which tends to give sounds a stronger, what people describe as punchy sound, which in the end, punchiness is really just our interpretation of it holding at full volume for a longer time, where that short spike of the ADSR is not really so natural. And the delay attack decay sustain release, which is more or less just the ADSR with a little bit of delay before it starts. I became kind of fascinated by the the attack hold decay. This is the envelope generator that appears in the Buchla music easel. And initially, I'm a Buchla tech. I've repaired a lot of vintage Buchla instruments and became kind of a specialist in the instrument. And a lot of what I've done is influenced by Buchla philosophy. So it was natural for me to wonder why Don Buchla would have used this or that in whatever he did. And what came up was on the internet a discussion about how the music easel's envelope generator has a flaw in the design. In fact, if you hold the key down, it doesn't continue to decay. It's supposed to, but it has a tendency to just fall off into oblivion. So in the process of coming up with a solution to fix that problem in my vintage music easel and also a friend's, I really started to think a lot about this shape. And in our world, where this West Coast Buchla world, where the majority of the time we're actually using sequencers, and as a musician, most of the music that I make is sequencer music, techno, and atmospherics and things. So I'm very rarely actually playing a keyboard. So the idea of being able to create this stronger punch hold shape and to create the shape that's always going to happen the same no matter how long the gate is, that's appealing to me. So I sort of started to cling to this concept of an envelope generator shape. And then when at our shop we started to talk about the possibility of what I was imagining as a polyphonic envelope generator or a chaining or what we sometimes called a strum envelope generator. The concept was that we wanted to have a group or a batch of more simple envelope generators that would happen all at the same time. At one point, Morten Subotnick told me that one of his favorite patch tricks was to have 3 or 4 envelope the simple attack decay type envelope generators happening on the same sound with different ones going to different parameters, like one bending the pitch, one controlling the volume, one controlling the wave shape or whatever. And so then when the attacks are not all synchronized together, then we can shape the tonality and the volume, the pitch, all these things separately and create more complicated and interesting varieties of timbres. So with a group envelope generator, you could do that, but you could also chain them one after another so that, a bit like strumming a guitar, you could introduce them in series or overlapping. So playing with that idea and with the idea of the attack hold decay envelope generator, then we started to come up with the genesis of a new module. So the polyphonic envelope is a new paradigm that we created out of this concept. So in this basic sense, this is just one of the possibilities of a shape that could come out of it. But we've now taken a simple attack hold decay envelope generator and created a more complex batch philosophy or combination function generator where we have the possibility of using each of those 4 independently, like in a polyphonic patch, or using them for 4 different sounds, but also to chain them together with control over what part of each one is triggering the next one. So this is a graph that is also on our t-shirt, but what's showing is that the first one starts out, and when it hits the peak of its attack, then the second one starts rising, and when it hits the peak of its attack, the next one starts rising, and so on, and then there's a cascade pulse output, which is the same function that was triggering the next one is triggering the outside world, whatever. So The module in question then is right here. So along the left side, we have the 4 gate inputs, and the right side, 4 CV outputs and pulse outputs. And those can be used, those gate inputs can be used independently for polyphonic patches, or they could all receive the same gate for that stacked envelope that Subotnick would use. Or they could be used for totally separate sounds because they're all independent. But then, should you decide that you want to work them together, then you have 3 modes where you can make it so that the next one is triggered by the beginning of the hold stage, or in the middle mode by the beginning of the decay stages, or by the beginning of the end pulses. And then, since you only have one set of controls to control the attack, hold, and decay of all 4, then there are master parameters or batch parameters so that you can skew across the 4. So the controls that are on the panel on these sliders are just for the first envelope, and then as we turn the attack skew, the subsequent ones, if we turn it to up, then the subsequent attacks will be slower, and if we turn it down, then the subsequent attacks will be faster. And that's true of the hold and decay as well. And then level tilt will allow the volume of the envelopes to be starting at 10 volts and getting quieter as we go down them, or starting quieter and getting to be 10 volts at the end. So now I'll demonstrate some things that can be done with this. So the first thing I want to patch is using a cascade to go across the 4 envelopes to open up the first 4 harmonics on a harmonic oscillator. So you can see that it's now in the hold mode, so the attack control is controlling the spacing between them. Maybe it takes some of the effect away. An interesting aspect of this is I've said, breaking free of the tyranny of the 16th note clock, because the polyphonic envelope has its own timing, because how quickly they roll out is controlled by their time constants. So within each note, we have some degree of its own timing that's unrelated to the clock, in this case, the sequencer. So if we skew the attack, we can hear how it's going from faster to slower. This is tilting, so the higher notes are quieter. And the other way. What happened? Okay. Okay, not sure what was going on there, but now the possibility is to have notes that are triggered by the main pulse output of the voltage multistage just triggering one envelope, and the only one triggering a cascade. So in this respect, then, the one note is playing all the time, except for accented strums across all of them. Another possibility would be to treat all four of them loop, because they all have end pulses. They can be looped. So it can be quite effective to use them each as LFOs that are, although the timing controls mean that they're all the same time constants, but a little bit of skew goes a long way to making them actually not all the same. This can be a quite nice drone. Or within the sequence, treating each one as the turning on from a different stage. And then using the all output. mess with it a little bit more, and then. Thank you.